Hello everyone. In last class we discussed the introduction part of the two-port networks. Okay, so in introduction class we discussed what do you mean by two-port network, what are the different types of two-port network parameters. So in this class we are going to see the in detail version of the one parameter jet parameters. So let us consider one two-port network having the two ports, one dash as input port and two dash as output port. Input voltage represented V1, input current I1, output voltage V2, output current I2. This is called as one two-port network. So what do you mean by jet parameters here? What are the combinations of the dependent and independent variables? If you express V1 and V2 as a function of I1 and I2, this we can call as a jet parameters combination. That means currents I1 and I2 are independent variables and V1 and V2 are dependent variables. We have to express V1, V2 in terms of I1, I2. So we have to obtain certain mathematical equations to express the voltage in terms of the currents. So in equation form, the above relation can be written as V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. This is equation 1 and 2. So in matrix form also we can express these 1 and 2 equations. V1 V2 is equal to Z11 Z12 Z21 Z22 in terms of I1 I2. So where we can represent this total mathematical equation V is equal to Z into I, where V is the vector representing voltages, Z represents the matrix 2 by 2 matrix representing Z11, Z12, Z21, Z22, where I1, I2 represent the current matrix. Now we have to obtain the individual Z parameters, assigning the values of the independent variables as a 0. So here we have the two different cases. Let us take one first case 1. Let us assume I2 is equal to 0. For the given network, we are making one independent variable I2 is 0. What is the meaning of making I2 0? Port 2 dash is open circuited. If you want to make the current is 0, you have to make port 2 dash is open circuit. Why? Because why we are making port 2 dash open circuited means current I2 is 0. Then from equation 1, we will get V1 equal to Z11 I1. So Z11 equal to V1 by I1. It is nothing but ratio of input voltage to input current. By making second port is open circuited, P by I, that's why the unit is ohms. That's why the name of the parameter Z11 is called as open circuit driving point impedance. Why? Because through input port we are driving this source, driving point impedance. By making second port is open circuit, we are finding these parameters. That's why this parameter we can call as open circuit driving point impedance. That's why these parameters also called as impedance parameters. Why? Because all parameters we will get V by I, V by I, V by I. So these parameters we can call as a impedance parameters. And next, by using second equation, we will get whenever I2 is 0, Z21 is equal to V2 by I1. So here we can call as this is open circuit. We are finding all Z parameters by making use of open circuit, either port 1, port 2. That's why all parameters we can call as open circuit parameters and impedance parameters. Open circuit forward transfer impedance. Why? Because one port to other port we are finding the impedance V2 to I1, forward transfer impedance. So by making one port is one port current is 0, we got two parameters. So to obtain the remaining two parameters, we have to make sure port 1 dash is short circuited. So that I am assuming as a case 2. Here we are making port 1 dash is open circuit. That means I1 is equal to 0. So when you make I1 is equal to 0, by using equation 1, we will get V1 is equal to Z1 to I2. That's why Z12 equal to V1 by I2 when I1 is 0. V1 by I2, voltage by current, that we can call as a impedance, and by making first port is open circuit, that's why the name of this parameter we can call as a open circuit reverse transfer impedance. So these parameters we can call as a open circuit reverse transfer impedance. So in other side, if you make port 1 dash open circuit by using second equation, V2 is equal to Z22 I2, that's why you'll get Z22 equal to V2 by I2. It's clearly showing to the second port, that's why we can say this parameter is called as open circuit driving point output impedance. So here we got the four parameters Z11, Z12, Z21, Z22. So all parameters having the ratios of V1 by I1, V1 by I2, V2 by I1, V2 by I2, voltage by current, voltage by current, voltage by current, by making any one of the port is open circuit. That's why this parameter is called as a open circuit parameters or impedance parameters. Okay, let us take down one simple T network. How can you solve that? How can you get the solutions for this two-port network? For the given network, V1 and the current is I1, V2 and the current is I2, and the resistance is here 10 ohms, here 5 ohms, here 15 ohms. Now, can you find the Z parameters for this? Now we know that to Z parameter equations are V1 equal to Z11 I1 plus Z12 I2, and V2 equal to Z21 I1 plus Z22 I2. So in order to make sure to find the Z parameters, we are making two different cases here. First case one, in case 1, what we are doing, first making port 2 to a dash is open circuit. So already the given network is showing open circuit, that's why I2 will become 0. So whenever it is open circuited, if you apply the KVL here, V1 is equal to 10 plus 5 into I1. So V1 is equal to 15 into I1. So Z11 is equal to V1 by I1, that is equal to 15 ohms. So whenever port 2 dash is open circuit, we got the open circuit driving point input impedance, we got 15 ohms. So by using same second equation, we have to get Z21. So how can Z21, which relates V2 and I1 whenever I2 equal to 0. So how can you determine V2 in terms of I1? V2 is voltage across 5 ohms resistor when it open circuited. So V2 equal to 5 times of I1. Why? Because same current flowing through the circuit. So Z21 is equal to V2 by I1, that is equal to 5 ohms. Now this is the way one can find the Z parameters for the given network by making port 2 dash is open circuit. We can now take down for the same network. I'm drawing once again same network 10, 5, 15. Case 2 is making I1 is 0. Whenever I1 is 0, we have to find, this is V2 and I2, V1 and I1. First parameter Z22, V2 by I2. So whenever I1 is 0, this port is open circuit. V2 is simply V2 equal to 15 plus 5 into I2. So V2 by I2 is equal to Z22, that is equal to 20. Next we have to, by using this first equation, we can get Z12 equal to V1 by I2. We have to express V1 in terms of I2 current. So here I2 current is flowing through the 5 ohms resistor, that's why V1 equal to 5 into I2. So V1 by I2 equal to 5 ohms, that is equal to Z12. So here if you observe these answers carefully, Z21 also we got 5 ohms. That means this is a symmetrical T network. That's why driving point, the transfer impedance V1 by I2 to V2 by I1 should be the same. That's why we got the answers here 5 ohms and 5 ohms. So this is a way, simple T network. Likewise, you can use the procedure to solve any big networks to get the Z parameters. So in next class we will see the remaining parameter, that is called as Y parameters.